Hi guys, it's Mrs. Harmison here with your physical science notes for section 5F.
First, we need to know how to tell if an element is a metal or a non-metal. On your periodic table, I wrote in this stair-step line right here. So this tells us where the metals and the non-metals are.
So up here are the nonmetals.
And that also includes hydrogen.
And then down here are the metals. An ionic bond is a bond between a metal and a nonmetal. In an ionic bond, the electrons are transferred, and then the atoms are held together by opposite charges. When you name an ionic compound, you're going to name it normally. All you have to do is change the end of the second element to "ide," and you are going to ignore the subscripts. So we're just going to write the first element's name, strontium, and you're going to write that exactly like it is on the periodic table. And then you're going to write the second element's name, but instead of leaving the ending like it is, we're going to change the ending to "ide." So O is oxygen, so we change it to oxide. CS is cesium, and on your periodic table, you're going to see it has a different spelling, C with an A in it. Either spelling is okay. So cesium, and then P is phosphorus, so we're going to change that to phosphide. Change the ending to "ide." Notice here we ignored this 3. We're going to ignore the subscripts. Okay, so in this one, aluminum has a 2, but when it's an ionic compound, we ignore that subscript, so it's just going to be aluminum. And again, on your periodic table, it says aluminum. You can write that, or you can just write aluminum. And then S for sulfur. But we changed the ending to "ide, so it would be sulfide. Okay, when you have a covalent bond and it forms a molecular compound, the naming will work different than in an ionic compound. First of all, as a review, a covalent bond is a bond between two nonmetals, and in a covalent bond, the electrons are shared. They're held together by the fact that they're holding on to the same electron. When you name molecular compounds, so if there are two nonmetals, you are going to name them with prefixes, and you are still going to change the end of the second element to "ide." You're going to have to use a list of prefixes, which you will find on the periodic table right over here. So I gave you that list of prefixes on the periodic table, so you're going to need to use those prefixes. And then the last thing you need to know is that there is an exception, and that is that you don't write mono on the first element, even if there's a 1 on it. Here is our practice for naming molecular compounds. Now, we're going to know that it's molecular if they're both nonmetals. Okay, so C, carbon, is a nonmetal, and bromine is a nonmetal. So we need to name this, and we do have to pay attention to the subscripts this time. There's 1 carbon here, and then there are 4 bromines. So since there's 1 carbon, the prefix for that would be mono. However, the exception states that we don't put mono on the first one. So the first element is never going to have a mono. So we just write carbon. The prefix for 4 is tetra, which you can see on your periodic table. So I'm going to put tetra, and then I'm going to put this element's name, but I'm going to change the ending to "ide." Tetra, and then Br is bromine. So I'm going to put brom, and then change the ending to "ide." So this is carbon, tetra, bromide. All right, this is water, as you can tell, but to name it as a molecular compound, we have 2 hydrogens. The prefix for 2 is di, so you are going to put the prefix on the first one if it's anything besides mono. So, and we put the di in, and then hydrogen is the element, and you don't change the ending of the first element. So we're just going to put dihydrogen, and then we have 1 oxygen. The prefix for 1 is mono, and on the second element you do put the mono on. So we put mono, and then it actually is going to be monoxide. We change the ending to "ide just like in all the others. If you wrote monoxide, it would end up looking like monoxide, and that is not correct. So you just take out that extra O, so it's monoxide. Dihydrogen, monoxide. All right, on this next one we have nitrogen. There's only 1 of it, so it would have a mono, but since it's the first element, we don't put the mono, so we just write nitrogen. And then we have 1 oxygen, so we are going to put, again, monoxide, nitrogen monoxide. And then on this last one, we have 2 nitrogens, so we're going to put di-nitrogen. And then there's 4 oxygens, so the prefix for 4 is tetra, and then we again put oxide at the end. Dinitrogen, tetra, oxide. Now we're going to be talking about polyatomic ions. A polyatomic ion is a group of atoms with a charge. And you're going to find the polyatomic ions on the list that I gave you. I put that list on Classroom for you, and it's also on the last couple of pages of this set of notes. And the tip-off for if you have a polyatomic ion is that there are going to be more than 2 capital letters, which means there's more than 2 elements in the compound. So if you see 3 or more capital letters, then you're going to know that there's a polyatomic ion. You are not going to change the ending of the polyatomic ion. However it's written on the list is how you will write the polyatomic ion. However, you will still change the ending of the element to "ide" if the second word isn't just an element. We are going to pay attention to the subscripts within the polyatomic ion, but we're going to ignore other subscripts. The first thing that you're going to have to do is pick out the polyatomic ion. So it's kind of harder in some, like this one, where there's no parentheses. You just have to get used to it though, and look on the chart and see, can you find an NH4 as a polyatomic ion, or can you find an H4Cl? Now, as you can see here, NH4 is a polyatomic ion. It's called ammonium. So you're going to write that name without changing it. So this would be ammonium. And then you're going to look up what the element is. So this element is chlorine. And we're going to change the ending of that element to "ide." So chloride. So this is ammonium chloride. On this next one, the parentheses help us to figure out what the polyatomic ion is. So this element starts with aluminum, so we'll write aluminum. We don't change the ending because it's the first element. You only change the ending when the element is the second. And then SO3. We have to look up SO3. You have to be really careful because there's going to be an SO3 and an SO4. And you have to make sure you get the correct one. So SO3 is right here, and that is sulfite with an I. So we have aluminum sulfite. You do not change the ending of the polyatomic ion. This next one, magnesium, Mg, is just an element, so you write magnesium. And then we have to look up Cn. Cn is right here. It is named cyanide, so we write cyanide, leaving it just like it is on the chart. And then this last one, sometimes you have 2 polyatomic ions together. So we have the NH4, which we already determined was ammonium, and then we have ClO, which is on the polyatomic ion chart. It's a little hard to find because that's not what the other chlorate's here though, and it is hypochlorite.
For this page, we're trying to determine if each of these is ionic, molecular, or polyatomic.
It's going to be ionic if the first element is a metal and there's only 2 elements. Sodium is found right here, so it is a metal. And since it starts with a metal and there's only 2 elements, this one is ionic.
C is carbon. Carbon is over here, and hydrogen is here. Both of those are nonmetals. So if you have 2 nonmetals, it's going to be molecular.
This one has calcium, oxygen, and hydrogen. And right off the bat, if we ever see 3 elements, we know that it's going to be polyatomic. Magnesium.
Magnesium is a metal. There's only 2, so this one's going to be ionic. I'll put an I.
Aluminum is right over here. It's near that stair-step line, but it's on the left side, so that classifies it as a metal. And so since there's only 2 elements and the first one is a metal, it is going to be ionic.
Here we have potassium and manganese and oxygen. Again, we have 3 elements, so that's going to be a polyatomic. And then we have
a nitrogen, which is up here, and an oxygen, which is here. Both of those are nonmetals, so this one's going to be molecular.
All right, let's first name the ionic ones. The ionic ones are super easy to name. All you do, write the first one's element name and write the second one's element name, but change it to "ide." So this would be lithium, and then phosphorus, we change to phosphide. Here we have magnesium, and then we have phosphorus again, so magnesium phosphide. Okay, second, let's do the molecular ones. Now, the molecular ones are the only ones that you're going to use prefixes for. And remember, you're not going to put mono on the first one. So sulfur, there's only one of it. The prefix would be mono, but you don't put the mono, so you're just going to write sulfur. And then there's 2 oxygens, so di is the prefix for 2. Oxygen, we change the ending to "ide," so it's dioxide. Here's another molecular one. We have a carbon. It would be mono, but we don't put the mono on the first one. There's 4 chlorines, so the prefix for 4 is tetra, and chloride. And then this last molecular one, 2 nitrogens, so I would write dinitrogen, and this one is oxygen, so I would write dioxide. And I want to point out the difference. We changed the ending of the second word to "ide" We don't change the ending of the first word. And then these last ones, you need to look up a polyatomic ion, so you'll need that chart. Ba is barium, and the polyatomic ion for OH is hydroxide. Al is aluminum. The polyatomic ion for SO3 is sulfite, and then K is potassium. And if you look up MnO4 on the polyatomic ion chart, you see that it is permanganate.